Welcome, curious minds, to the deep dive. Today, we're plunging headfirst into a topic that has, well, really changed its public image. It's moved from just whispers and grainy photos right to the forefront of serious government attention. Unidentified aerial phenomena, or UAPs.
That's right. Remember when it was all just UFOs? Flying saucers, little green men, that whole image.
Exactly, often, tinged with a bit of ridicule. But now, the language itself has fundamentally shifted.
And with it, the official approach, which is maybe even more significant.
Yeah, what was once pretty much dismissed as fringe fantasy is now being seriously investigated by agencies like the Pentagon, even NASA.
It's undeniable, really. UAPs aren't just back in the public conversation, they're firmly on the government's agenda now.
It feels like a huge shift from decades of, well, denial or at least institutional dismissal.
Oh, absolutely. It's an evolution towards a cautious but definite acknowledgement. A colleague, Luis Elizondo, who was involved in those early military intelligence efforts, he put it very bluntly. The United States government is telling you that UAPs are real.
So the conversation now isn't if they exist, but more like, what are they? And why might they be a challenge?
Precisely. That's the core question now.
And that's exactly our mission for you today. This isn't just a quick summary. We want this to be a science-first breakdown of this whole disclosure moment. The idea is to give you the knowledge to sort of separate the real data from all the hype and speculation out there.
Yeah, there's a lot of noise. Our goal is to help you cut through it.
So we'll cover UAPs 101, the definitions, the sensors involved, and maybe crucially why eyewitness accounts, even really credible ones, just aren't enough for solid scientific proof.
Exactly. And then we'll get into what agencies like ARO, that's the All-Domain Anomaly Resolution Office, and NASA are actually saying officially. What's confirmed, what's still inconclusive.
And how to spot those sort of clickbait claims that just seem to muddy the waters, right?
Definitely. We'll also revisit some of the really famous cases, like the Tic Tac incident. We'll look at what parts of those stories actually hold up under scrutiny, and maybe what parts fall apart a bit.
And importantly, we'll dive into the common explanations. Things like balloons, drones, even just glare or sensor glitches, what some people call sensor ghosts.
Yeah, the mundane explanations that account for a lot of sightings.
We'll show you how to vet claims using solid methods, thinking about chain of custody for evidence, the need for multiple sensors backing each other up, looking at metadata.
All the critical stuff for validation.
And finally, we'll zoom out a bit and look at the policy side of things, government transparency efforts, FOIA, that sort of thing, and maybe talk about realistic timelines for actually understanding this whole complex field.
It's a lot to unpack, but getting these nuances is really key to grasping the bigger picture.
Okay, so let's start our deep dive. To really get into this, we first need to get our terms straight. What exactly are we calling UAPs now, and how has that terminology itself kind of changed the game? What's the difference between the old UFO and this newer UAP?
That's absolutely fundamental. The shift from UFO, unidentified flying object, which always had that, slightly sensational vibe,
Right, very sci-fi.
to the current, much more neutral UAP, unidentified aerial phenomenon, is completely intentional. Sometimes you'll even hear unidentified anomalous phenomena.
To include things underwater or in space, too.
Exactly. It broadens the scope beyond just the air. But the key word in all of this is unidentified. It means just that, unexplained. It doesn't automatically mean aliens or anything sinister.
It's just we don't know what it is yet.
Precisely. It's a term rooted in scientific neutrality.
Yeah.
It just signifies something that we can't immediately explain through conventional means. And honestly, many reports do end up having perfectly ordinary explanations. Weather balloons, drones, maybe small aircraft people didn't recognize.
Like that Canadian system, Craze. They lump UAPs in with weather balloons and meteors.
Yeah, the Canadian Civil Aviation Daily Occurrence Reporting System does just that. They categorize UAP reports under headings like weather balloon, meteor, rocket, UFO and intelligence sighting, or laser interference. It shows the wide range of possibilities they consider first.
So it's about casting a wider, more objective net. That makes sense for science. But here's where it gets tricky and maybe frustrating for some people: the evidence itself. Why aren't eyewitness accounts, even from really credible people like military pilots, usually enough for scientific proof? I mean, if a trained pilot sees something wild, isn't that pretty strong evidence?
That's a really common question, and it goes right to the heart of how science works. Anecdotal evidence, even from trained observers, can definitely motivate an investigation. It can point you in the right direction.
It tells you something's worth looking into.
Exactly. But it doesn't constitute scientific proof on its own. Human perception is incredibly complex. Even for highly trained people, it can be affected by stress, lighting conditions, atmospheric distortion, fatigue, cognitive biases.
Or just being confused by something totally new.
Right. All these things make accurate, precise observation really challenging. For a scientific study, especially when you're dealing with things that seem to define known physics, you absolutely need quantitative measurements.
Hard data.
Yes, precise, objective data from well-calibrated instruments. Measurements of speed, altitude trajectory, energy signatures, maybe even material composition if possible. Without that, it's incredibly hard to rule out things like misperception, sensor errors, or even just conventional explanations that weren't immediately obvious.
That difference between anecdotal evidence pointing the way and hard scientific proof is so important. Can you give us a historical example, maybe where compelling eyewitness accounts initially led scientists down the wrong path?
Oh, definitely. The classic example is probably the Martian canals. Back in the late 19th, early 20th century, really respected astronomers like Schiaparelli and Percival Lowell using the best telescopes they had.
They thought they saw canals on Mars, right? Like artificial waterways.
Exactly. They reported seeing these intricate straight lines crisscrossing the surface. Their observations were detailed, they were enthusiastic, and for many people, it seemed like solid evidence of intelligent life on Mars. But then other astronomers with better and better instruments over decades just couldn't reliably see them. It eventually turned out that these canals were basically optical illusions.
Illusions. How?
Often, it was the human brain connecting faint, unrelated dots or features under difficult viewing conditions. The brain wants to see patterns, especially lines. So the anomaly wasn't on Mars. It was often in the observer's perception, a huge lesson in the limits of observation.
That's a fantastic illustration. What about the opposite, where something was initially dismissed by experts despite eyewitnesses, but later turned out to be real?
That's just as important, and meteorites are the perfect example. For a long, long time, leading scientists and philosophers during the Enlightenment, including the great chemist Lavoisier, they simply dismissed the idea that rocks could fall from the sky.
They thought it was impossible, even with people saying they saw it happen.
Yes. Despite centuries of accounts, eyewitness reports of stones from heaven, the scientific thinking of the time just couldn't accommodate it. They'd explain it away as lightning strikes or weird atmospheric events.
So what changed their minds?
It really took Jean-Baptiste Biot's incredibly thorough investigation of a huge meteorite shower over L'Aigle, France in 1803. He didn't just dismiss it. He went there, interviewed hundreds of witnesses meticulously, collected the actual physical samples, scientifically documented the whole event.
He gathered overwhelming evidence.
Exactly. His rigorous work eventually started to chip away at the skepticism. Later, the discovery of asteroids provided the source, and analyzing the composition of meteorites finally convinced the scientific community. The lesson there is that refusing to believe things just because they don't fit your current understanding can be just as misleading as believing in things that aren't real.
Both sides of the coin. You need that open-mindedness, but also the rigor.
Precisely. Which brings us back to UAPs today.
Right. So for that small subset of UAPs, the truly weird ones that really do resist easy explanation after that first look, what are their commonly reported characteristics? What makes them so baffling?
This is where the reports, especially from credible sources like pilots or radar operators, get really specific and, frankly, mind-bending. They often describe simple geometric shapes, spheres, disks, cubes, triangles, cylinders.
But no wings, no engines.
Exactly. Critically, no visible wings, no jets, no rotors, no propellers, none of the things we associate with flight. Witnesses often report a complete lack of sound, which is bizarre for anything moving through the air at speed, or sometimes really unusual high or low pitch sounds.
And they interfere with equipment, too.
Frequently. Reports often mention strong, localized magnetic fields causing compasses to go haywire, or nearby electronics and machinery suddenly malfunctioning or shutting down entirely.
Silent, weird shapes messing with electronics. It does sound like science fiction.
And it gets even stranger physics-wise. They often display high luminosity, sometimes associated with high-energy electromagnetic emissions, particle emissions, or even residual radioactivity being detected afterward.
But the movement, that's the really impossible part, isn't it?
That's arguably the most challenging characteristic. The reported maneuverability and acceleration are just extraordinary. We're talking about objects allegedly going from a dead stop to tens of thousands of kilometers per hour, like instantly.
The G-forces would be insane.
Exactly. Forces that would tear apart any conventional aircraft, well, liquefy any biological pilot. Think about the structural integrity needed, the kind of propulsion system that could do that without any visible means. It's staggering.
And they can just vanish.
They're often reported as having low visibility or appearing to just disappear, become cloaked somehow, which makes tracking them even harder. These impossible traits, the extreme speed, the lack of sonic booms when they apparently break the sound barrier, the instant direction changes, the silent flight, that's what makes them truly anomalous. They fall way outside the known phenomenological envelope of current science and technology.
And these aren't just one-off, vague descriptions. They're specific, repeated observations from multiple, often highly trained people. It really challenges our current understanding.
It absolutely does.
Okay, let's shift gears now from the phenomena themselves to the official response. For so long, the U.S. government line on UFOs was basically denial, or maybe some dismissive explanation. But there's been this huge change, hasn't there? From denial to, well, acknowledgement. What happened to push this into the open?
It really is a profound shift. It wasn't just one thing, but a combination of factors. Persistent reports from military personnel were a big part, sightings that couldn't just be brushed off as mistakes or equipment failure.
And national security concerns.
Definitely. Plus growing national security worries. Remember, Project Blue Book officially shut down in 1969, concluding there was basically nothing worth investigating further. That was the public face for decades.
But things were happening behind the scenes.
Oh, yes. Interest continued, and quiet programs existed. We had ATIP, the Advanced Aerospace Threat Identification Program, from around 2007 to 2012, partly funded by Senator Harry Reid. Then later, the UAP Task Force, UAPTF, from 2017 to 2022.
But the big turning point was around 2020, when the Pentagon actually confirmed these programs.
That was huge. The Pentagon publicly confirming a defense program was collecting data on military UFO sightings. That confirmation, largely pushed by the leak of those famous Tic Tac and Gimbal videos.
The ones we'll talk more about later.
Right. That really moved the conversation from just speculation to official acknowledgement. The government's position now is explicitly that UAPs are real. And a key driver was also the realization that if these weren't ours and weren't easily explained, they could represent a foreign adversary's tech, a major intelligence gap, and a potential threat. They couldn't just ignore that possibility anymore.
That makes sense. So that brings us to ARO, the All-Domain Anomaly Resolution Office. That's the latest, most comprehensive version of this official effort, right? What's its mandate? What's it trying to do differently?
ARO was set up in 2022, taking over from the UAPTF. It reflects a much broader scope and a more formalized structure. The key is all-domain, investigating UAPs not just in the air, but also sea, space, and even on land.
Recognizing they might not just be flying objects.
Exactly. And that you need interconnected sensors and analysis across all those areas. AIRO's focus areas are really broad. Surveillance, collection, recording, looking at system capabilities and design, intelligence operations and analysis, figuring out mitigation and defeat strategies if needed, governance and oversight, and pushing forward the science and technology related to UAPs. They even appointed a new director, John Kozlowski, in August 2024, signaling it's an ongoing serious effort.
Okay, so what have their official reports actually said? Have they confirmed any of the wilder claims? Crash ships, alien bodies, that kind of stuff?
No, not at all. And this is really crucial for listeners trying to separate fact from fiction. ARO's big report in March 2024, the Report on the Historical Record of U.S. Government Involvement with UAP, Volume I, stated very clearly it found no empirical evidence of alien technology.
No evidence. That directly contradicts a lot of the disclosure talk online.
It absolutely does. Similarly, a report back in December 2022 said that while they'd received several hundred new UAP reports, there was no evidence of alien life or alien technology found in that data.
So it's this interesting tension. They're confirming UAPs are real, they're getting hundreds of reports, but they're firmly saying no alien evidence found so far. What about things like that story about a Pentagon official suggesting an alien mothership? Where does that fit in?
Ah, yes. That's a perfect example of the kind of clickbait or speculative claim that ARO's official, more cautious reports are trying to counter, or at least put in context. In March 2023, there was a speculative paper co-authored by a Pentagon official hypothesizing about an alien mothership potentially using tiny probes in our solar system.
But it was just a hypothesis, not a finding.
Correct. It was presented as a possibility in a scientific paper, not a confirmed fact. And it was met with considerable skepticism, even within the UAP community itself. Representative Eric Burleson, who's on the Oversight Committee, called it far-fetched, questioning why advanced aliens would crash here anyway. AARO's job is to stick to the verifiable evidence, and those kinds of hypotheses, while maybe interesting to think about, are very different from their official conclusions.
Okay, that distinction is important. What about NASA? Where do they fit into the UAP picture?
NASA brings its huge reputation for scientific rigor and public transparency to the table. They set up their own independent study team, releasing a report in September 2023. Their focus was really on how NASA could use its scientific expertise and its vast network of sensors, Earth-observing satellites, space telescopes, to help understand UAPs better.
But did they find any evidence of aliens either?
No. Just like ARO, the report explicitly stated they found no evidence of extraterrestrial origin for the UAPs they looked at. NASA's commitment is really to apply their standard, high-rigor scientific methods to this problem. They're essentially saying, if there's data, we'll analyze it seriously, but we're not jumping to conclusions based on speculation.
It's definitely good to hear that serious scientific bodies are tackling this with established methods. But even with this shift away from denial, there still seems to be a lot of congressional scrutiny, maybe even some lingering stigma around the topic. Why do you think that hangs around?
It's complex, and the stigma is definitely still there, despite the national security angle. You hear people like Senator Marco Rubio expressing concern, but his concern is primarily framed as either a potential technological leap by an adversary country,
Like China or Russia?
potentially, or he says it could just be a boring conventional explanation we haven't figured out yet. His main focus isn't little green men, it's potential threats to U.S. security. And then you had that House oversight hearing in 2023 where Representative Tim Burchett explicitly mentioned the stigma on Capitol Hill, saying some colleagues still giggle when the topic comes up.
That kind of attitude must make serious investigation harder.
Absolutely. It can hinder getting resources allocated, and it definitely discourages military personnel or pilots from reporting what they see for fear it'll damage their careers. It's a cultural hurdle that official acknowledgement hasn't entirely cleared yet.
Still a tough conversation in some circles. So what really stands out to you about this whole official picture right now?
The crucial thing, I think, is that distinction. The government acknowledges the reality of unidentified phenomena, things seen on sensors that aren't immediately explainable. But they have not acknowledged an extraterrestrial origin for any of it. That's a subtle but really vital difference that often gets lost. It shows a commitment, at least officially, to sticking only to what's verifiable.
Right. Acknowledging the mystery, but not jumping to a specific unproven answer. Okay, so let's move from the official stance to the actual sightings. Let's talk famous cases. And maybe the most famous, especially since videos were officially released, is the Nimitz incident from 2004. Can you set the scene for us? What happened there?
The Nimitz encounters are definitely a cornerstone case, partly because we have validated footage and first-hand accounts from highly credible people. It was November 14, 2004, off Southern California. The USS Nimitz Carrier Strike Group was doing standard training exercises.
A whole fleet of ships.
Exactly. And a key ship was the USS Princeton, a missile cruiser with the SPY-1 Bravo radar, a really top-of-the-line air defense system. For about 2 weeks before the main event, the Princeton had been tracking multiple anomalous aerial vehicles, AAVs.
What were these things doing that got their attention?
The radar showed them behaving incredibly strangely, descending from maybe 80,000 feet down to 20,000 feet in less than a second.
Wow, that's unbelievable speed.
Then hovering, then zipping off again.
Right.
Totally unlike any known aircraft. On the day of the main encounter, the Princeton's radar operators, like Senior Chief Kevin Day, had the best possible track quality on these things. They knew they were real, solid objects, not radar glitches. They were a major concern because they were unidentified in military airspace and moving in ways that seemed impossible.
And then they sent the fighter pilots, right? Commander David Fravor was one.
Yes. Fravor and Lieutenant Commander Alex Dietrich were flying FA-18F Super Hornets. They were vectored to investigate. Fravor described seeing this little white tic-tac-looking object hovering silently over a weird patch of turbulent water below, like the water was boiling, but the object was above it.
A tic-tac, how big?
He estimated about 40 feet long. Smooth, white, no markings, no wings, no exhaust plumes, critically, completely silent. And then, as Fravor descended to get a closer look, the object started mirroring his movement.
Mimicking him like it was aware.
That's exactly how he described it. It suggested awareness, intelligence. He said, it was aware we were there. This thing was not doing what a normal aircraft would do.
That's chilling. What happened when he tried to engage it to get closer?
This is where it really defines physics as we know it. As Fravor tried to cut across his path, it accelerated instantaneously, just gone from his sight, vanished. Seconds later, the USS Princeton picked it up on radar again, 60 miles away.
60 miles in seconds. The speed is astronomical.
Senior Chief Day later did calculations suggesting it dropped from 28,000 feet to just 50 feet above the water in 0.78 seconds. That implies a speed over 24,000 miles per hour. And crucially, no sonic boom was detected.
Which should be impossible at that speed, right? It would be deafening.
Exactly. Breaking the sound barrier, especially that fast, should create massive sonic booms. Their absence is a key reported anomaly.
And didn't it go into the water, too?
That's another really bizarre part. Sonar operators on other ships reportedly confirmed the object submerged seamlessly, then moved underwater at around 500 knots. Again, defying both aerospace and hydrodynamic principles.
Incredible. And then there's the famous FLIR video, the Tic Tac video itself. Who recorded that?
That was Lieutenant Commander Chad Underwood on a later flight. His FA-18 had an advanced infrared camera, the FLIR. He was focused on getting the data recorded, capturing it on sensor. He actually coined the Tic Tac name based on how it looked in the infrared display, although he didn't see it with his own eyes.
His job was to get the evidence.
Right. The video shows this white, oblong object, no obvious propulsion, moving erratically.
So you have sophisticated radar, multiple trained pilot eyewitnesses, infrared video, even sonar data. What happened after they got back to the ship with all this?
This is where the story gets really troubling for many people and feeds into those cover-up narratives. According to accounts, soon after the intercepts, plainclothes individuals arrived on the Nimitz, possibly by helicopter.
Not regular Navy personnel.
Apparently not. They reportedly took the air crews aside, debriefed them, and essentially told them this event did not happen. Then they were made to sign non-disclosure agreements, NDAs.
Telling them it didn't happen and making them sign NDAs, that sounds like suppression.
It certainly raises serious questions about the chain of custody for the data and suggests an attempt to control the information, which obviously fuels suspicion.
And wasn't there talk about a longer, clearer video than what was eventually released?
Yes. Petty Officer Jason Turner described seeing a much longer, higher-resolution version of the FLIR footage on the ship's internal network. He said it was about 10 minutes long, showed strange appendages coming off the object, and depicted it going berserk with impossible maneuvers. He also claimed that longer video was later wiped. Again, this reinforces concerns about transparency and data integrity.
It's easy to see why the Nimitz case is so central to this whole discussion. Were there other major U.S. military sightings after that?
Yes, definitely. Another significant series of events happened between 2014 and 2015, this time with the USS Theodore Roosevelt carrier strike group operating off the U.S. East Coast.
Pilots like Ryan Graves.
Exactly. Lieutenant Ryan Graves and other FA-18 pilots reported seeing UAPs almost daily for months, sometimes years. These encounters produced the other famous videos, Gimbal and Go Fast.
What did the gimbal video show?
Gimbal shows an object rotating against a strong headwind at high altitude, seemingly with no propulsion. The pilots in the audio sound baffled, remarking on the fleet of them. They describe these objects as having no exhaust, no heat signature, no rotor wash, yet capable of hypersonic speeds and strange maneuvers. These weren't isolated incidents. They were repeated, systematic observations by multiple pilots and sensors.
And it's not just a U.S. thing, is it? Other countries have their own famous cases.
Absolutely not. This is a global phenomenon. Canada, for example, has some really well-known incidents. The Royal Canadian Mint even put 5 famous cases on collectible coins.
Like Falcon Lake and Shag Harbor.
Precisely. Falcon Lake in 1967 involved a prospector allegedly getting burned by exhaust from a landed disc. Shag Harbor, also 67, had multiple witnesses, including police, see lights crash into the water off Nova Scotia, leading to a big Navy search, though nothing was found.
And the Montreal incident.
That was 1990. A huge, luminous oval object seen by many over the city, including police, but nothing showed up on radar. These cases, like Nimitz, involve compelling observations that defy easy explanation and have stuck in the public memory in Canada. It underscores that these aren't just happening in U.S. airspace.
So we have all this radar, video, pilots, global reports. What's the official or expert take on what actually holds up scientifically? Even with these really compelling cases, what do the formal assessments conclude?
It's really important to grasp the cautious official stance. That ODNI preliminary assessment in June 2021 looked at 144 military UAP reports. Their main conclusion was a lack of sufficient data to determine the nature of these objects.
So still unidentified.
Basically, yes. While they acknowledged some reports, appear to demonstrate advanced technology, things like the high speed, the acceleration, the lack of sonic booms. They also stress these observations could still potentially be sensor errors, electronic spoofing by adversaries, or just observer misperception.
They aren't jumping to conclusions.
No. The report explicitly said these cases need additional rigorous analysis and multiple types of data before any definitive conclusion can be reached. So the phenomena are acknowledged as real unidentified events, but their actual nature, scientifically, remains unconfirmed. The caution is understandable given the potential for misinterpretation and the advanced conventional explanations, like electronic warfare, that might be involved. We have data points, intriguing ones, but not yet enough to connect them all definitively.
Even the best cases still need more data, which leads us perfectly into discussing the more common, less exotic explanations and how we sort through all the reports.
Exactly. Separating the signal from the noise.
Okay, so we've looked at the official shift and some really puzzling cases, but now let's ground ourselves and talk about the more common explanations. What often gets mistaken for a UAP, a big factor you mentioned earlier, is this idea of the democratization of air power. Can you unpack that a bit? How does that affect UAP reports?
Sure. Democratization of air power basically means that thanks to technology getting cheaper and more accessible, a lot more people and groups have access to things that fly. Okay. It's not just big military forces or airlines anymore.
You mean like drones?
Drones are a huge part of it. Commercial drones, tiny micro drones, hobbyist drones, but also things like high-altitude balloons launched by civilians or researchers with cameras and GPS. Private companies are using aerial devices for deliveries, inspections. Even foreign actors who aren't nation-states might use them.
So the skies are just busier, with more types of things.
Much busier, and with a wider variety of objects. A RAND Corporation report pointed out that this makes public UAP reports potentially useful for spotting new threats. But it also means a lot of reported UAPs are probably just human-made things that weren't recognized. That could even include classified U.S. military aircraft sometimes.
That makes total sense. So given all these extra things in the sky, what are the most common false positives? What gets misidentified most often?
Balloons are a classic. High-altitude weather balloons, research balloons, even that big Chinese surveillance balloon that got shot down in early 2023. They can look weird at altitude, drift slowly, catch the sunlight.
Even just party balloons.
Oh, yeah. Especially metallic ones, maybe clumped together, seen from a distance against a weird sky. They can definitely cause brief, confusing sightings.
And drones, obviously, must be a huge factor now.
Massive. The sheer number of commercial and hobby drones out there is staggering. They're different sizes, the sometimes erratic way they fly, their bright lights at night. If you're not familiar with them, they can easily look anomalous. They can hover silently, move quickly.
Things that might seem impossible for a plane.
Right. Remember that Canadian KDOR system data? UAP sightings were something like 0.08% of pilot reports in 2023. A tiny fraction compared to all the known aerial activity. It shows how rare the truly unexplained stuff likely is.
What about natural things? Do people still mistake planets or clouds for UAPs?
Absolutely. Astronomical phenomena are a very common source of misidentification. Bright planets like Venus or Jupiter, especially near the horizon, the moon sometimes, bright stars, meteors.
And Starlink satellites. I hear those cause a lot of reports now.
Yes, Starlink satellite trains, especially right after launch when they're in that straight line formation, are a major source of confusion for people who don't know what they are. They look like a string of lights moving steadily across the sky.
And atmospheric stuff.
Yeah, things like mirages that distort distant objects, lenticular clouds that look uncannily like flying saucers. Even distant lightning or reflections can be misinterpreted.
Okay, so we have human stuff, natural stuff. But what about more advanced things like sensor ghosts or electronic warfare? Could that explain some of the really weird maneuvers, like with the Nimitz case?
This is a really critical area, especially for the military reports. Electronic warfare, or EW, techniques like radar spoofing, are designed to actively deceive sensors.
How does that work?
Basically, an EW system can transmit false signals that trick a radar into thinking there's an object where there isn't one, or it can distort the signal returning from a real object, making it seem like it's moving impossibly fast or changing direction instantly. It creates false velocity and position data.
So the sensors report something impossible, but it's not physically happening.
Potentially, yes. Think back to Nimitz, the reported uniform heat signature, no visible propulsion, combined with the incredible speed and maneuvers. Theoretically, that could be consistent with certain kinds of advanced electronic deception designed to confuse or mislead an opponent's sensors.
So maybe an adversary trying to trick U.S. systems, making them see phantom UAPs or making normal planes look extraordinary.
It's a plausible scenario that intelligence agencies take very seriously. Could adversaries have developed EW capabilities to exploit weaknesses in U.S. systems, to create false tracks, hide their own assets, or just test U.S. defenses? It's a major national security concern, completely separate from any alien hypothesis, and it highlights why having multiple different types of sensors confirming something is so important.
Right, cross-validation. And finally, we have to touch on hoaxes. People faking sightings. Does that just discredit the whole field?
It's undeniable that hoaxes happen. Many famous old UFO photos turned out to be fakes. But acknowledging that shouldn't invalidate the entire scientific question. The history of science has plenty of hoaxes. Remember Piltdown Man?
The fake human ancestor skull.
Right, a huge, elaborate hoax that fooled scientists for decades. But finding out it was fake didn't stop the search for real hominid fossils, which were eventually found. The existence of hoaxes just means we need more rigor, more skepticism, better verification methods. It doesn't mean there's nothing real to investigate.
It raises the bar for evidence, which seems appropriate. So what's the main takeaway for you from all these common explanations?
I think the crucial point is that the vast majority of UAP reports probably do have conventional explanations, whether it's misidentification, sensor artifacts, or even deliberate spoofing. But that small percentage that remains truly anomalous, after rigorous checking the ones seen on multiple sensors doing things that defy known physics, those are the ones that demand a dedicated scientific approach, precisely because it's so easy to be fooled. Hoaxes and mistakes are a reason for more rigor, not dismissal.
Which brings us perfectly to, how do we vet these claims scientifically? How do we apply that rigor? The Galileo project seems to be leading the way here. What's their approach?
The Galileo project is really interesting because it was started specifically because past UAP investigations often lack that scientific rigor and reliable systematic data. Their core idea is simple. If the phenomenon is real, it's measurable.
They want to collect their own data, not just rely on old reports.
Exactly. They're motivated by those historical examples, like the Martian canals or meteorites, to avoid both misidentification and premature dismissal. Their whole approach is about generating new, high-quality, independently verified data using a whole suite of calibrated instruments, rather than just analyzing potentially flawed historical data or eyewitness accounts. It's proactive data collection.
So they're building observatories. What kind of instruments are they using? It sounds complex.
It's incredibly comprehensive. They call them multimodal ground-based observatories. Multimodal meaning they use lots of different types of sensors. They have wide-field cameras covering different parts of the light spectrum visible, infrared to spot things, track them, and use triangulation to figure out their exact position and movement, their kinematics.
And then they zoom in.
Right. They have narrow-field instruments, specialized cameras to get details about the object's shape, its morphology. They use spectroscopy to analyze the light it emits or reflects that can tell you about its temperature or chemical composition, like astronomers analyzing starlight. And polarimetry, which measures how the light waves are oriented, giving clues about the object's surface. Is it metallic, smooth, rough?
Like a remote analysis of the object itself?
Pretty much. Beyond cameras, they use passive radar arrays, multiple receivers listening from different angles to pinpoint location and movement very precisely, providing backup data. They have radio spectrum analyzers to listen for any signals the object might be emitting, or control signals like from a drone.
And they listen for sound, too, since many UAPs are reported as silent.
Yes, microphones covering everything from infrasound to ultrasound. That silence, or lack of expected sound, would be a key data point. Plus, a whole suite of environmental sensors, temperature, pressure, magnetic fields, even energetic particle detectors, like muon detectors. The goal is to have multiple independent ways to detect and characterize anything unusual, and also to rule out instrument errors or known phenomena.
That's an incredible amount of data. Processing it and making sure it's reliable must be a massive job, especially if you're looking for rare anomalies.
Data integrity and processing are absolutely central. They use cutting-edge AI techniques for multi-sensor data fusion, combining all those streams into one picture. They use machine learning for classification, figuring out what's known, like planes, birds, satellites, and crucially, algorithms designed for outlier detection to flag anything that doesn't fit the known patterns.
And validating the data, making sure it's not just a glitch or dust on the lens.
Constant validation is key. They have processes to meticulously identify and exclude instrument artifacts, those just donuts you see on cameras, lens flares, cosmic ray hits on sensors. If a measurement is underdetermined, meaning it lacks accuracy or resolution, it gets flagged. They want only pristine, reliable observations in the final scientific dataset.
What about preventing tampering? That Nimitz issue with seized tapes and wiped data is a big concern for trust.
They've designed their system specifically to address that. They use strong cryptographic methods for data storage, like AES encryption, hash checks, checksums, to verify files haven't been altered, multi-factor authentication for access, and cryptographic signing to prove data authenticity and origin. The idea is to make the raw data verifiable by outside researchers, building trust through transparency and security. It directly counters those past chain of custody problems.
So, with all this robust data, how does the Galileo project define a true scientific anomaly? What makes something really stand out for them?
Their goal is to find phenomena unknown to current science that resist explanation by widely accepted scientific beliefs. So they establish a clear baseline, the phenomenological envelope of everything known.
Like the maximum speed of a jet or how fast a balloon can go?
Exactly. The absolute limits of performance for all known aircraft, missiles, natural phenomena. They track known aircraft using transponder data, for instance, to define what normal looks like. For something to be a candidate anomaly for them, it has to dramatically exceed those known limits in multiple ways at once.
Not just slightly faster, but way off the charts.
Way off, like showing acceleration far beyond our best missiles while hovering silently and maybe being able to go underwater seamlessly, all without visible propulsion. If it performs within the known limits of any existing technology, even classified stuff, they wouldn't classify it as a scientific anomaly by their strict definition. It has to be statistically distinct in ways that defy all conventional explanation. And that they're collaborating with the DoD's ARO office, so there's integration with government efforts too.
That's a really high but necessary bar. And they're not just looking up, right? They're also doing this extraterrestrial archaeology.
Yes, that's a fascinating and unique angle. Unlike traditional SETI, which mostly listens for radio signals from far away, the Galileo project is also searching for physical evidence, technological relics, maybe left behind by probes from civilizations that might not even exist anymore.
Relics? Like what?
Their most public example is the expedition to recover fragments from the first known interstellar meteor, IM-1, that hit the ocean near Papua New Guinea in 2014. Initial data suggested it was made of unusually strong material and entered the atmosphere at high speed.
So they went looking for pieces of it on the ocean floor.
Exactly. The goal is to analyze those fragments to see if that unusual strength comes from some kind of artificial alloy rather than just being a weird space rock. Finding something like that would be, well, revolutionary.
Truly groundbreaking. So they're actively searching for physical proof, not just waiting for a signal. On the flip side, what about existing public databases like NUFORC, the National UFO Reporting Center? They have tons of reports. How useful are they scientifically?
NUFORC is a huge repository, over 100,000 sightings analyzed in that RAND report. But for rigorous science, it has major limitations. There's no control over how the data is collected. It's all self-reported by people with varying skills and biases.
You get duplicates, misidentifications.
Right. Multiple reports of the same thing, reports by the same person over and over, reports that aren't really UAPs at all. And crucially, UFORC doesn't have a formal process to verify the claims or apply scientific filters. It's basically a collection of raw, unvetted anecdotes.
So how did RAND try to make sense of that data? How did they find patterns like those hotspots?
They had to use statistical methods to try and clean it up. For instance, raw sightings just map population centers, more people, more reports. So RAND adjusted for population density. Interestingly, they found population density was negatively associated with sightings per capita.
Meaning rural areas have a higher rate of reports.
Per person, yes. Fewer people. But maybe clearer skies or other factors lead to a higher reporting rate relative to the population.
And did any areas still stand out as hotspots after those adjustments?
Yes, places like Maricopa County in Arizona or Los Angeles County in California still showed a statistical excess of reports compared to their population. But even then, those hotspots could be due to other things. Maybe better visibility, proximity to military bases or airports, local culture encouraging reporting, or just more media attention making people look up more. It highlights why controlled data collection, like Galileo's, is so vital. Public databases are interesting, but not enough for scientific proof on their own.
It really underscores the complexity. It's not just about seeing something, but how it's reported, collected, and rigorously analyzed.
Exactly. The methodology is everything.
Okay, we've covered the science, the cases, the explanations. Let's broaden out to policy and transparency. How are governments, especially the U.S., handling this increased focus and public demand for information? There seems to be a real push for more transparency lately.
There definitely is. The Freedom of Information Act, FOIA, is the main tool for public access. Though it can be a slow and challenging process, the Office of Information Policy, OIP, oversees how agencies comply. We've seen recent talk about improving things, like that potential executive order on gold standard science and its FOIA implications, aiming for more scientific integrity in government data.
And using AI to make FOIA requests easier.
Right, upgrading FOIA.gov search tools. These are steps towards making information more accessible.
But there's still this tension, isn't there, between government secrecy, maybe for legitimate security reasons, and the public wanting to know, especially about UAPs. Sites like the Black Vault seem to highlight this constantly.
That tension is absolutely real and persistent. The Black Vault does great work using FOIA. They've shown, for example, the Navy withholding hundreds of pages about why they released certain UAP videos, basically blocking further insight. They've also reported on CIA mishandling old Soviet UFO files, losing potentially valuable info.
And that connects back to the Nimitz case, with the NDAs and seized tapes.
Exactly. Those past actions, that opacity, even if intended to protect sources or methods, inevitably fuels public mistrust and the very conspiracy theories the government says it wants to combat. It's a difficult balance. Secrecy erodes trust.
It's a tough line to walk. What about other countries? Are they doing things differently? Any models for transparency we could look at?
Yes, several countries have different approaches,
Mm-hmm.
and France is often cited as a model. They have JIPEN, it's part of their National Space Agency, CNES, and it's been around since 1977.
What makes JIPEN different?
Their whole mission includes collecting reports, investigating them scientifically, archiving them, and proactively releasing their findings to the public. They operate on principles of transparency, neutrality, public service, and respecting witnesses. They even work with educational groups to help the public understand common misidentifications. It's a very open, integrated approach.
That sounds really proactive. Any others?
Chile has CEFA, an official body within their Civil Aviation Authority, also committed to transparency, publishing regular reports. Germany has a nonprofit citizen science group, GEP, that investigates public reports and publishes findings, though they find conventional explanations for over 90% of cases.
And Canada. You mentioned the Sky Canada project finding gaps there.
Right. Canada's approach has been more fragmented. The Sky Canada project pointed out the lack of a standardized system, no official public reporting platform, limited analysis, unless it's an immediate safety issue, and not enough scientific involvement, which allows misinformation to spread. Their recommendations include having a lead agency, maybe the Canadian Space Agency, setting up a public service like GPAN, and encouraging reporting without stigma. We're also seeing renewed interest elsewhere. Japan formed a UAP group in 2024, and China had research groups back in the day. There's a growing global recognition that better, more transparent systems are needed.
Which leads to the huge challenge, combating misinformation and building trust. With so much stuff online, how do we help people find reliable information?
It's incredibly difficult. Conspiracy theories about UAPs and government secrets are widespread. That 2019 Gallup poll showing 68% of Americans think the government knows more than it's telling. That's significant.
And people tend to believe the first thing they hear, right? That cognitive bias.
Exactly. Once a false narrative gets traction, it's really hard to correct it just by debunking it later. That's why proactive strategies seem more effective.
Like pre-bunking, getting the good information out there first.
Precisely. Pre-bunking, providing accurate, contextualized, understandable information before the misinformation takes hold, seems to be the best way to inoculate people against it. It's about filling the information gaps proactively. And the key players here are trusted figures, especially scientists, engaging in open, transparent dialogue. When institutions seem secretive, misinformation thrives. By sharing what is known and being honest about what isn't known yet, you can build trust and make people less susceptible to sensational but unfounded theories. That's why the work of ARO, NASA, and projects like Galileo is so important. They're trying to fill those gaps with actual data.
It really brings it back to that core idea. It's not just a scientific journey, but a societal one about trust, transparency, and verifiable information.
Couldn't agree more.
So, as we wrap up this deep dive, let's pull together the main threads. What have we learned exploring disclosure or delusion in this current UAP moment? It's clear UATs are now firmly in the realm of official investigation and serious science.
That's the big takeaway. While the sensational stuff is still out there, the real focus for agencies like AR and NASA and scientific groups like Galileo is on rigorous, data-driven analysis. There's been a definite shift from just speculation towards systematic, careful investigation.
We're seeing progress in defining terms, setting up dedicated offices, developing sophisticated methods to study these things properly, respecting the evidence or the lack of it.
It's not about proving one pet theory. It's about applying solid scientific principles to things that remain genuinely unidentified. Those persistent anomalies, the credible reports, the sensor data, they're finally getting the serious scientific look they deserve, instead of just being dismissed or explained away too quickly.
We're moving beyond just UFOs to a more nuanced, evidence-based approach to UAPs.
The challenge, as we've said, is huge. It requires rigorous checking, eliminating mundane explanations, maintaining data integrity, especially in today's information environment. But committing to that rigorous analysis, even if it doesn't give us easy answers right away, is a massive step forward for both science and public trust.
And that leads us to a final, maybe provocative thought for you, our listener. Think about the history of science. It's full of things once deemed impossible that later became accepted facts.
Heavier than air flight, continental drift.
Even meteorites falling from the sky. All were ridiculed or denied because they didn't fit the accepted science of their time. They were outside that phenomenological envelope.
So given that history, and the fact that some UAP reports do persistently defy conventional explanation despite decades of skepticism, what if the hardest part isn't finding the evidence?
What if the real challenge is for us society, science, to actually accept an answer that falls dramatically outside our current understanding?
What if the biggest hurdle isn't technology, but psychology, philosophy?
Whether the final answer turns out to be super advanced human tech we don't know about, some natural phenomenon we haven't grasped yet, or something else entirely, something beyond our current concepts. What does accepting that actually look like?
How would a truly paradigm-shifting revelation reshape our science, our technology, our whole worldview, our place in the cosmos?
And maybe most importantly, how do we prepare ourselves, individually and collectively, for a reality that might demand we fundamentally rethink what we believe is possible?
It's certainly something to mull over.
Indeed. Until our next deep dive.